Hey, here's the in-class work for 813 today. We're going to talk about the shape and spread, and the big thing that we'll work on is called absolute mean deviation. What a messy thought process, and it kind of seems a little long, but once you get the hang of it, it kind of goes quick, quite honestly. So today, working on that, like I said, that shape and spread. Before we get started, I'm going to jump ahead down here to the math notes. This is a spot that has the mean absolute deviation and kind of what it is and what we're trying to get from that stuff. So this might be a good resource if you're struggling a little bit with this one. So what we have here is Mrs. Ross is the school basketball coach. She wants to compare the scoring for the two different games, number of points scored by each player of the game shown below. So, for example, player 1 scored 12, player 2 scored 10, player 3 scored 10, etc. How many total players are on the team? Well, since we are talking two different games, right? Not total. This is just going to be 10 players. Right? What is the mean number of points for each game? If we add them all up, right, it's the total number of points, right, divided by the total number of values. In this case, it's the total number of points divided by the total number of players. If we add up game 1, we get 100 points, 10 players for an average of 10. And if we have game 2, you'll get 100 points for 10 players to get 10 each. That's kind of intentional. They want you to look at those, although I didn't take some time just to look at them, so that you can really kind of break them down and say, well, which game turned out to be better, right? Okay, which game turned out to be better? It kind of looks almost like that top one with a lot of double digits, but we'll find out. What's the median? Median, again, is that middle number, right? So when we do that middle number, we always want to put them in order, which I already did for you to kind of help this process through. And then what you're going to do is you're going to kind of work your way to the middle of that, to find that middle number, right? But because it's 10, it's an even number, you will have two numbers in the middle, right? So what's the number between 10 and 10? 10. So the median for game 1 is 10. Now, I've been showing that cross-off method, but if we had 100 scores, you would never want to do that. So what you need to start thinking about is how you would do this if you had 100 scores or whatever it happens to be, right? And how you would do that is you would realize that since you have 10 scores, and that's an even number. If you have an even number, you're going to have 2 in the middle, so you're going to have to find that. If it was an odd, like 9, you would have one single number in the middle. So what you do is you would go 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5. And notice I have my two numbers there. And what's between 9 and 11? Right? Well, we could add them up. And then we could divide it by 2. Holy cow, it's the same number. Yeah, are we getting the theme here? 10 players, mean of 10, median of 10. What's the range of points? Oh, come on, that can't be 10 also, is it? Well, for game 1, we take that largest value, it's 14. Oh yeah, way to go. And we take away that smallest value, 14 minus 4, it is 10. I bet you could probably figure out what it is for game 2. 14 minus 4. Okay, so the range for both is 10. Okay, so with your team, discuss and find another method for comparing the data. Oof. Well, if you were to discuss this with your team, one way you could do is to graph it, right? A graph would be about the only other thing that we could do that would really help us out. And we're going to do a histogram in just a moment, so I'm not going to even show that histogram now, right? Otherwise, it really seems as if all the data is the same, which is weird because all of the other things line up, so it must be the same. But if we go back up here and look at them, do they really feel the same? I don't know. All right, so do you think scoring in 2 games is equivalent? For right now, it kind of looks like it. Yes. But of course, why would we give you such a nice little easy problem without having more things for us to do, right? All right, let's move on then. Using the data from that problem, create a histogram for both game 1 and game 2. Make intervals of points. Make intervals of 2 points. How are the games different? Well, I already set that up for you. And I set that up as 0, 2, 4, 6. Those are the intervals of 2 points. So what we're going to do is we're going to go back up. And we have a 4, 8, 9, 10, right? And I am not going to jump back and forth, but the very first one I had was that 4, so I'm going to go under that 4, and I'm going to make a 1, right? Fill that in. We have in 2 8s, I believe, or was it an 8 and a 9 from in here? Again, I don't want to go 8 and a 9, so we just had 2 of them, right? So under this group of 8 to 10, we had 2 of them, right? We had an 8 and a 9. We had 3 10s. Actually, we had 3 10s, but then we also had an 11, so I should go up 1 more. I believe it was an 11. And then this one will go up 2 also. I'd had this kind of pre-made ahead of time on the side, and you can double check my numbers if you really want, and this should be a 1. Okay. Now if we jump over to game 2, what we found is that from 4 to 6 we're going to have a 1. We're going to have another 1 at 6 to 8. We're going to have 3 here, 1, 2, 3. Whoops. Another 1 here, 2 here, and another 2 here. Okay, that's what that should come out to look like. How can you measure the spread? So here's kind of the big thing for today, right, called mean absolute deviation. And they're going to guide you through how to find that mean absolute deviation. So all of A right here, I'm going to show you in the box. Okay, so you don't even have to necessarily follow all of that stuff. Step 1 is to make sure that for game 1 we put all the numbers in there. And in your document, I notice you don't have all your numbers, so I just put them all in here. So all of your data values go in here. So difference means subtraction. So how far is it from the mean? How far is that number from the mean? So where did they get that 2? Well, that's 12 minus the mean, 10. This is 10 minus 10 to give you 0. This is 10 minus 10 to give you 0. 8 minus 10, that's a negative number. There we go, sorry. At least once a video, right? Minus 2, 11 minus 10 is 1, 4 minus 10 is negative 6, 0, 4, 2, and you have a negative 1, okay? And what they do then is they take the absolute value of those numbers, and you will find out why we need the absolute value in just a little bit. All right, so when we do the absolute value, what do we get? We have absolute value of 0. How far is 0 from 0? It's 0. 0. How far is negative 2 from 0? It's 2. How far is 1? 6, 0, 4, 2. And how far is negative 1 from 0? It's 1. Okay. So we've actually listed it. Second column, we did that. We did the absolute values. Now we're going to calculate that. What we do is we add up all these numbers over here. I shouldn't really make them look like it's a 1 or something like that. But what I'm doing is I'm going to add up all of those numbers right there. Okay, we're going to add up all of them. And I do have that somewhere. I need to pull that back out here somewhere. All right, there it is. And when we add those all up, we will get 18. Calculated the sum. Now we're going to divide by the number of data points. Well, we already know we had 10 players, right? 10 games. So then what we do is we take 18, we divide it by 10, and we get 1.8. Okay? So the mean absolute deviation for 1.8 or for game 1 is 1.8. Mr. Crone, what in the world does that mean? Let's do the mean absolute deviation for game 2, and then let's talk about what that actually means, okay? All right. I put in the values. I already kind of went through some of this. 1, 2, 8 minus 10, negative 2, 13 minus 10 is 3. Again, where did these all come from? I should have just taken a moment, pause, talk about it. That's all of our data values. This is how far. What in the world? That's annoying. That's how far each of these values are from the mean, and then we took the absolute value of those numbers. So I was just filling in the difference from the mean, right? 9 minus 10 is negative 1, 14 minus 10 is 4, 4 minus 10 is negative 6, 8 minus 10 is negative 2. Okay. Absolute value of each of those numbers, the absolute value of negative 3 is 3, absolute value of 4 is 4, absolute value of 1 is 1, absolute value of 2 is 2, 2, 3, 1, 4, 6, and 2. When we add up all of those, the sum of all of that is 28. And we take 28 and divide it by 10, because we have 10 players, and that will become 2.8. So that's that 28 divided by the number of players, 10. Okay. Now, what does this tell us? Well, if we would have sat and read through that math notes box, we would actually find that the mean absolute deviation for game 1 is 1.8, and for game 2 it was 2.8. And what this tells us, and I'm going to jump back up here to take a second to look at this, is how far, so we'll just call it the mean absolute deviation, the MAD of this one. I just made that up. That's not really a math term. The mean absolute deviation of game 2 is 2.8, right? I think it was 2.8. Yes. And what that tells us is the data in game 1, when we have a smaller mean absolute deviation, is it's more compact. It's not so spread out. What it is all that data is just kind of closer together. When that mean absolute deviation is larger, that means that we've got much more spread out scores. But Mr. Crone, it doesn't feel like it, right? Well, what happens if you take a look at kind of the different data, right? I have one data point in game 1 from 4 to 6, and I have one here, right? But I have an extra one here where I don't have one in game 1, right? And then I kind of have these, like I got a larger clump over here, where over here I didn't have quite that clump of stuff. So what I've done is we've taken those scores and just kind of like spread them out a little bit, okay? And that allows us to, it's another way of just looking at data and understanding it, right? So does this method of showing the average mean distance from the mean help to distinguish between the two games? Yeah, it does. And what does it do? The mean absolute deviation shows how spread out the data is. And I'm going to say compared to other data, right? All right. Did you notice how absolute value was used to calculate the mean deviation from the previous problem? What would happen if you did not use the absolute value? Use your data to demonstrate what would happen. Well, let's jump back up here. What they're really asking you is if you didn't do this step right here. Whoops. If you didn't do this step right here, right? You didn't do the absolute value, and you just added all of these numbers, what would you get? If you didn't do this and you added all of these numbers, what would you get? Well, I put all the numbers down there for us to actually add up. 2 plus 0 is 2, plus 0 is 2, minus 2, or plus a negative 2 is now back to 0, so 0 plus 1 is 1, minus 6 is negative 5, plus 0 is negative 5, plus 4 is negative 1, negative 1 plus 2 is positive 1, and a negative 1 is 0. And if we add up all these numbers, we're going to get the exact same thing, 0. By the way, when I look at these, I try to look for groups that will cancel each other out. That's kind of my goal. So like, for example, I saw that this 2 and this negative 2, they cancel each other out. Right? I saw that this negative 1 and this negative 3 will cancel that 4. Right? What else do I see? I see this is a 1, 3, and a 4. That's a positive 8. Positive 8. Well, this is negative 8. They all cancel out, right? That's another way of doing that. Why is it important to use the mean? So what would happen to it? Well, it really wouldn't be very helpful because it would be 0 for every single one. Because what we're doing is finding out how far the numbers are from the average. Well, of course they're all the same. For as many numbers that are above the average, we're going to have below the average. Why is it appropriate to use the mean instead of the median to analyze each of the basketball games? In this case, we would want to use the mean. Oops, I gotta just get my sheets and stuff like that here. The mean is really a good choice because, quite honestly, we don't really have any outliers. Maybe the median would be a better choice, and I don't know. Actually, we don't do that this year. Maybe the median would be a better choice if we did have outliers, right? So, no outliers. Why not use the mean, right? Okay. So lastly, or not lastly, I guess, but kind of the big focus for the last part of this will be about naming data. So when we went back up top to that Game 1, Game 2 histograms, we can give these specific names. We have names. We have what's called a double peaked and a single peaked. I tried to keep those separated. By separated, that's why I put them in a different color here. And then what we have is we have kind of, I'll choose another one, skewed and symmetric. Skewed and symmetric, I'm trying to think, you cannot be skewed and symmetric at the same time. And then uniform, although I'm putting in a different color, really could be kind of tied up with some of the other ones. So let's go ahead and name some of this stuff down below here. Give these some names. Let's see if we can't figure out the double peaked and single peaked. When I look at the first one, A, and it does not look very peaked at all. It doesn't look very, I know it's up and down, but you have to think about it kind of more of like in general. We look at B though, and we have B is what we would call a double peaked. Why? Because it goes up, comes down, goes up, comes down, and that's kind of that double peaked sort of look. Since this one comes up and then comes down, I bet you could figure that one out. That's a single peaked, right? And let's look at D. It comes up and it still comes down a little bit. That one's also single peaked. Oops, singled. That's not frustrating. There we go. Yeah, this program's not making me super excited here. Let's look at the blues now. Skewed and symmetric. They're kind of alike. They just can't be the same, I guess, at the same time. The skewed part is one that probably haven't heard this vocabulary word very much, but if something is skewed, it leans one way. And the only one that really fits that is D. This is skewed. It's pushed to one way. That's what we would call skewed data. Do we have some symmetric? Symmetric means that if you kind of put a mirror in the middle, would it look the same? Yeah, we do have some, and we would call this one symmetric. And I know it's not a perfect symmetric. No data would really be very perfect, but we would want it, is it close? And the answer is yes, it is. And actually, we would say that this one is symmetric, very close to it. The single peaked one is also symmetric. This D is not very symmetric at all. The right side does not kind of mirror the left side. And then the last thing is uniform. Is it kind of, if it's uniform, it's going to be something where it's going to be much more like the same all the way across. And as I look at it, the only one that fits for that would be this one. It's uniform data, and why? Because it's kind of pretty much straight across there. See, the data in B comes up and goes down. So you would not say double peaked, single, or single peaked, right? Double or single peaked with uniform at the same time. It's just not, that can't happen. You could not say skewed and symmetric at the same time. You cannot say double peaked and single peaked at the same time, right? So that's kind of why I always separated those out. All right, so we're going to look at the histogram now we created, and in 31, which words from there in 35 could we use to describe them? Well, let's go back up. That is right here. Here we go. I would look at this and I would say, well, game one definitely probably looks what? Single peaked. Game two, it's not really single peaked when it comes down and jumps back up. It's more, this is not even a great one, it's more uniform. It's not even very uniform, quite honestly. This one is probably, oh man, it's really hard to see or to tell if you'd want to like pick one thing or another. I'd probably just say single peak. You could argue that this one is somewhat symmetric. It's not very symmetric because of that one, right? It just kind of like hangs way out there. I don't know. I don't know if I'd put much more in there. This data is, we'd need more data to really make great decisions on the words for that one. So, come on. Let's get that here. Here we go. So everything after this is what we would have, those extra kind of problem that would be helpful. The set of the data at the right is organized in a frequency table. If you were to create a dot plot, just did it for you by the way, how would you describe the shape using the words that we listed above? Well, let's use those same words. I would call it single peaked, right? Definitely looks like that. I would say that it looks symmetric. It's not double peaked. What other words do we have in our thing? I wouldn't call it uniform, and it does not appear to be skewed, does it? Okay. How many total scores are there? Well, what we're doing is looking here, right? We had one score of 1. We had 5 scores of 2. So this is how many times it happened, and how many do we have there for total scores? We had, I think it's 50 if I remember right. Again, getting my numbers in front of me. Yeah, it is 50. Using that table, calculate the sum of all the scores. So if, I'm sorry, I'm doing my multiplication in here a little backwards. If I had one score of 1, then I had a total of 1 there. If I had a score of 2, 5 different times, that's 10. If I had a score of 3, 12 different times, that's a total of what in the world? 36. It's really hard. I do not like this. And if we continue down, 60, 55, 24, and 14. Add those all up, and we get a total of 200. Is it appropriate to calculate the mean? Yeah, I would say it is. I mean, looking at the data, it looks like it should be. Yeah, of course. It doesn't look like we have a lot of outliers, do we? If so, what is the mean? Well, then we have a total of 200 between 50 different scores, right? And so 200 divided by 50 is 4. 4 would be our mean or our average. That was convenient. So when I was working through this and calculating the mean absolute deviation for this one before, I kind of cheated just a touch. Here's what I mean by that. I I went through and I started to do the mean absolute deviation, I put all the scores here, right? How far are they from the mean? So 1 minus 4 is negative 3, 2 minus 4 is negative 2, right? And what I did is I filled in the rest of I could fill in the rest of these, right? This would be negative 1, 0, because 4 minus 4 is 0, 5 minus 4 is 1, 6 minus 4 is 2, 7 minus 4 is 3. And what I did then is I took each of those numbers and I did the absolute value of them. Okay, that's what that column under that arrow means. Now, where did all those come from? Well, I had to keep the frequency of this. I had five different scores of 2. So I had to do a 2 times 5 to get to 10, because if I did all of those separate 2s and I wrote them all out, they would have become a 10. So what I'm trying to say is I cheated, and when I was working through this one, I did it before I read this additional challenge. Is there a different way to set up the table so you don't have to list all the data points individually? What they really mean is I would have had to do a 1 in my mean absolute deviation, then 5 2s. Then I would have had to subtract each one from 4 and find the absolute value. And I'm like, why would I want to do that? That's foolish. So instead, I already came up with this system to try to cheat and say, you know what? I already have 5 2s. And that's how I did that right there. And I did the same for 1s and 4s and 5s, 6s, and 7s. That gives us a total of 50. So to do that mean absolute deviation, we had 50 here, and remember we had to divide it by the total number of scores, which was 50. So 50 divided by 50 gives me a MAD, or a mean absolute deviation, of 1. So I kind of cheated and went ahead, and if you are not believing me with all of that stuff, go ahead and write it out: 1, 2, 2, 2, 2, 2, and then do 12 3s and 15 4s and 11 5s, and yeah, then you'll find out. I would take a second, just kind of write out what it does, right? What is that? When is it appropriate? It's not something you would need to do all the time, because you can see it's very time consuming. What I would say is you want to do that when all the other stuff just doesn't help, right? All the means were the same, all the medians were the same, all of the ranges were the same. And they don't have to all be 10s, but when each set of scores were the exact same, it really is hard to tell. So that mean absolute deviation allows us to see, right? What does it allow us to see? The spread of the data. That's what that does, right? All right, answers are, well, you can go back and look at that. Answers are here, right? More answers. There's your homework. Take your time, do your best, make sure you show your work, right? I want you to be in that proficient and robust area there. I tried to give you plenty of room to do that stuff, to solve that stuff, and your homework answers are at the end. All right, if you have any other questions, please let me know. Have a fantastic day.